If we've taught fractions and decimals very well, then percents are usually not quite so difficult for students to understand. They can understand what percents mean. However, using percents in the real world can be very, very confusing for students. And moving between all the different things that represent a part of something, a part of a whole, that means fractions, decimals, and percent, can also be difficult. Sometimes we ignore the conversion part, and I think that's an important thing for students to practice and understand, because then they can realize that we have different ways of showing a part of something, and there are certain situations where one of those ways is better than another. When we work with percent, it's nice to use situations that students can identify with. For example, this problem. Bobby and Karen might be names of students in your class, and maybe your students are old enough to understand that kids could be making money by mowing lawns in the summer. That makes it a little more relevant to them. Pause the video, and as you look at this problem, think about all the different ways that students could solve this problem. This would be a good one for them to do on their own so that you can see all the different ways they're thinking. Then start the video again and see if any of your thoughts match mine. So first of all, I would want my students to be thinking 40% is less than half, so Bobby's going to make less than $300. $300 is half. He's not going to make that much because he only gets 40%. They might be thinking then that 40% is 40 hundredths, which is 4 tenths. So they're going to take 4 tenths of the $600. So $600, and they're taking 4 tenths of it. That means taking it times 4 tenths. So they're going to get this answer if they multiply. We know that their answer should be close to $300, so the decimal would have to go here, and Bobby's going to make $240. So again, what we're doing here is actually conversions. We're making sure that students understand what that means. 40% is the same as 40 hundredths, that's the same as 4 tenths. That understanding is very important. Some students may also understand that 40% means 40 out of 100. So 40 out of 100 means they're going to make 40 cents out of every dollar. So they might say, well, 40 cents out of every dollar, and there are $600, so I'd have to take that $600 times 40 cents to see how much Bobby would make. And of course, I'm going to get the same answer that I got when I did the problem here, $240. Students might also be thinking, if Bobby's getting 40%, that means that Karen's getting 60%, and they may think of it that way. 60% means she's getting 60 cents on every dollar, and they might think about the difference between Bobby and Karen and what they make, and the fact that adding it up would have to equal 600. There are so many different ways for students to think about a problem like this, and we want them to do that kind of problem solving in ways that make sense to them. We want to encourage different ways to get to the answer, and we want students to share those different ways with each other. Percents represent things in the real world. We use percents all the time, and one place we use them is in business. So if students read this problem about Jaime and Zanika, we might want them to think about making money, profit, and all those ways that percent is actually used in the world. Pause the video and think about all the different ways you would want students to approach this problem. What do you think is important? This is another place where it would be a good time to show that numbers are all about relationships. So I actually might have my students make a little table for this. And I might have them think about the fact that 40 cents is what it costs them to make a bracelet. And they want to make 75% profit. So the question is, what do they have to charge then? We want students to understand that if they want to make 75% profit, that means the cost would be 25% of the 100%. The 100% would be the whole, that would be what they want to charge. So they can think about this as 40 cents as it relates to what they want to charge is 25% out of a whole, out of 100. 25% out of 100 is 1/4. So that means that the 40 cents that they charge would be 1/4 of what they would need to charge to be able to earn that 75%. So they can think about 1/4 is 40%. That means 4/4 would be 160 cents or $1.60. So if they charge $1.60 for each bracelet and it costs them 40 cents to make each bracelet, that means they're making $1.20 on every bracelet, which would be 75% profit. Later, of course, we can get into teaching students how to do this cross-dividing and saying, well, that would be the same as 4/10 or 2/5, and then they can do it mathematically. Thinking logically is actually much more important. If we're making 75% profit, that means 25% is our cost. 25% is our cost, that's 40 cents, that's 1/4. So that means this would have to be 1/4 of this number, and they can think about what that means. If 40 cents is 1/4, that means 4/4, the whole, would have to be 160 cents, or $1.60. With something like percent that is used so much in the real world, it's all about practical things. It's all about thinking logically. Another place that students might come upon percent in the real world is actually in their classroom. Sometimes teachers and schools use percent to keep track of how students are learning. For example, if you look at this problem, Gina took a test that had 25 questions. 25 is the whole test. And she has to get 80% of those right to be able to master that skill. So 80% represents the part of a whole. She had 20 answers correct out of the 25. 20 is the part that she got right. How did she do? Did she master it? Again, a table is a nice way for students to think about this. They can think about parts and wholes. Gina got 20 problems correct, that's the part, out of 25, that's the whole. Well, we know that 100% is the whole. So how would we get from 25 to 100%? We would be taking it times 4. So Gina got 20 right. If we take that also times 4, that means she got 80%. So did she meet the 80% mastery level? The answer would be yes, because we have part to whole, part to whole. And if those equal the same, then she did meet the 80% level. If students have been taught this well, there are so many ways they could prove their answer. They could use fractions. They could say, well, 20 over 25 is the same as 4/5, and 80 over 100 can be simplified to 8/10 or 4/5, and those are the same. So 20 out of 25 on the test is 80 out of 100, which is 80%. Take a look at this chart and fill in the conversions. Let's think about equivalent fractions to decimals that have hundredths to percent. What kind of thinking would you put into this? So if you were thinking about just a regular fraction here, and maybe a fraction to a decimal here, and here a decimal which is getting at hundredths, and here a percent, what kind of thinking would you use? Pause the video and complete the chart using a think aloud. What is your language? There are lots of different ways to think about this, but for me, if I were working with students, I would be thinking 1/2 is the same as 5/10, which can be written like this. 5/10 is the same as 50 hundredths. 50 hundredths is the same as 50 out of 100, and the percent sign says that for me. In this row, I have 4/10, which could be written as 4/10, which could be written in a simpler fashion as 2/5. 4/10 is the same as 40 hundredths, and that's the same as 40 out of 100, or 40%. 75% is the same as 75 hundredths, because 75 out of 100 is 75 hundredths. I can't make that a simpler decimal, but I could write it as a fraction as 75 over 100, and I could simplify that to 3/4. This is complicated, but we want students to understand that there are many ways to represent a part of something, and there are times when one of those ways may be better than another. And a very good way to reinforce that is to bring in real-world applications of fractions, decimals, and percents, and have them convert back and forth and talk about why one way of representing that part was chosen over another.